Oh, yes. The machine can do it. This is the first. In the future, there will be many more computing machines, thinking machines.
In a shed down by the docks lives a very clever box, and its children will one day rule the world. Only one man knows the potential that it shows, how its DNA will spread throughout the globe. Each time we can't explain what it's for and what its aim, with physics, text of algebra and sum. But built with his own hand, he can't really understand how important it will be in days to come. Vive the difference, engine, lurking in a Limehouse backstreet shed.
James, you're on.
Where's James?
James, why do you always do error?
Come on, LibreOffice PowerPoint conversion. You know you can do it.
Looks happy.
So,
Okay, so when Steve put these up for error handling as one of the topics for these, I decided to try and use it as a means to find some time to play with an idea that I wanted to do some of our reuse code to simplify some of that. So the first thing I want to say is this is really not so much about driving it through your application. I've thought about this long and hard, and especially after some of the discussions at the CLD Summit, this was brought up quite a bit. And the traditional way of using your arrow-wise to change stuff, your case structures and your sub-VIs, I think I'm still happy with this. I think it's the best way that we have right now. I think it fits data flow is the big thing for me. I don't like the idea, and when I've worked in other languages where you have things like exceptions and it fires off to some other handler, I think that's just conceptually a lot harder to understand how the application is going to act. So I like it, although it is a bit of a pain in the backside setting this up for every single sub-VI. I get lazy sometimes if they're not doing very much, like just a bit of maths or something, but generally I'm happy with this. What I really wanted to focus on is what you do next when you have an error occur. Because this is something that, as I've gone through a few projects now, I'm noticing some patterns in the way I like to do things, but I'm doing everything from scratch. It's laborious. And when something's laborious, you don't do it unless you have to. So rather than having the first thing I do, drop in some error handling, it tends to be, oh, it's a couple of weeks in, I'm generally happy with it. How am I going to deal with error handling? Which is the wrong way around. So there's a few existing solutions. One of my favorites is the structured error handler, if you've ever seen that. So that is like a little express VI, combined with it has like a central handler template as well that works with that. But it still lacks a few things. Obviously, you've got the simple error handler and LabVIEW. That I'm not going to start going into too much on that, but it's not the ideal solution for a lot of customer-facing stuff. So the first thing I want to do is write as little code as possible. I'm lazy. I like to think that helps on occasion with things like this. As well as a standard error cluster, there's a couple of standard extra bits of information I like to capture with errors. The first is kind of an application level source. What I mean by that is this loop or that loop, or in some cases where you might be dynamically generating loops. So I have one system where we fire off a new loop to talk to different devices depending on how many we have. I want to know which device threw the error, not just that it happened to be in that call stack. And I should say, actually, I read this again. I do still want the call chain. That's invaluable as well, but this is kind of additional information on top of that. The other thing is fairly standard is a severity and a level. It's kind of hard to know what to pick here, but I do use it from time to time to be able to differentiate between something that might be critical or something that might be not a normal error, but something that maybe I don't need to take quite as severe steps to kind of cope with. The other one bugs me because there's a bit of me that says that it's not error handling. But I also find I often add to my error handling solutions a way to record debug messages. mainly driven by the fact that the output for them is often the same. So if I've got an error log or I've got an error reporter, if I want to include debug messages, I normally want to send them there as well. The other thing I want to do is decouple transmission from handling. What I really mean by that is I want to be able to drop something in my code that says handle errors, and then centrally I want to say, when I get an error, this is how I want to react to that. As opposed to somehow tying the process of, oh, well, if I'm putting this error handler here and I'm using a central error handler, oh, now I don't want a central handler, or vice versa, I need to change that code to do that. So sorry, here's some OO. I generally do things in object-oriented programming, and for me, this seems like it has an opportunity to kind of help out with this case. I don't know how well you can read it. As long as you can read the top bits, don't worry too much about these, because I've changed my mind on a lot of them anyway. Basically, the idea is that the center of this all is an error object. This is really just my way of adding to the error cluster that additional information, having the source location, having the severity. There are some extra bits. What I really like is a much easier way of getting the full LabVIEW error description instead of going and hacking into the simple error handler on everything. If you haven't done it before, there's a really handy VI at the middle of that will take an error code and give you LabVIEW's description for it. So I'd include that as part of that as well. Then at the top, we've got the error dispatcher, and that is basically my bit that I can drop into all of my code and say, handle an error. If there's an error on the input, handle it. But then what I want to do is specify centrally how errors are handled. So that's what this guy here is. This would basically be like a parent error handler object, so that I can then create child classes of that, which might be a simple dialog, or writing it to a log file, or sending it over to a networked error logger or something like that. The other thing that is really useful in that structured error handler that I mentioned is the ability to filter and act on different errors in different ways. So if you never used it, you basically get a dialog where you can say errors in this range, classify them as this, or errors in this range, classify them as this, or ignore these errors, or there's some quite complex rules you can build. So I'd also look to include like a filtering element that would let you do that. It would let you say, oh, if it's got this, if it's in this error range, actually that's not a critical error, that's just a warning, or something like that. What this would actually look like in LabVIEW is something like this. Basically, what I'm thinking is you'd have at the start of your program some instantiation of your kind of core methods of handling errors. So in this case, I want to use a dialog and generate an event when there's an error. And the idea is you could queue up as many of these. So on one application, for example, I have at least 3 different techniques we use right now. We send it over the network, we write it to an error log, and if it's critical, we stop the application. So I wanted to support multiple different handling methods. What I really want this to do is to be easy, and to me, one of the things that's frustrated me with a lot of my current methods is I don't really like using functional global variables. I like wires generally, but I find some of this kind of application stuff, it's a bit of a pain having wires trailing everywhere. So I'd wrap this all up into a sort of global API. So at the start, we can register our handlers globally, and then anywhere where we want to handle errors, we drop in the handle global handle errors method.
You'll see something uncanny in my presentation.
And this is often how I use it. So we give it the name of the loop, or if it's more complex, I can just pass whatever string in there I want. Normally what I'll do is I'll classify everything from one source as one type. But this is where you could start doing funky things with filtering if you wanted to. And then, yeah, the kind of world is your oyster. Then you can just build different handlers to deal with different ways, and cope with it how you want. So it's turned into a bit more of a proposal than a debate. But this is kind of what I'm thinking, and I'm starting to try and kind of flesh out as something, certainly for myself, would be a flexible way of being able to do this in a lot of different applications. And that's all I've got. I didn't even pay attention to the time.
Very good. Come past that one in a minute. I didn't see any of my slides. Oh, I was whining about that earlier, mate. So, one of the things you demonstrate. I think you might be up next. Let's have a look. Not brightness. Fine. That's all. Oh, it's function key. F5 I was pressing. You're up next, or do you want? Yeah, you go. Let's do it in the right order.
Oh, so pretty.
Okay, I want to talk about error handling is extended to asynchronous loops that are talking to each other, so actors or similar kind of thing. So this is what, to me, is a very common kind of error case where some kind of action is triggered, do something, that goes through some code, and of course you have error handling at the end, which often for some kind of user thing is just to display the error. And so again, it's called error chaining. If you have an error somewhere in this chain, it just moves through all the other code to the end. And so anything that is in the middle, even sub-PIs, the error just passes through everything. And there's a standard error behavior where if you're supposed to do something, you don't do it unless you're cleaning up something, and then you do it. So that's actually kind of simplifying, and I like it. But when you get to like loops talking to each other, what do you do? So here, it's a complicated thing where an action is sent. One loop tells another thing to do something, passes along, and then the results come back. So what you really want to do, I think, if you have an error partway along this chain, you actually want it to have the same behavior where the error just passes through the whole thing. So that you have the initiator of the action handles the error, because the person who initiated the action is the person who knows what to do if there's an error, right? So if an error happens here, this doesn't really know. It's just doing its little part of some overall thing. It doesn't know what to do with the error. You want the error to actually pass through back to whatever is at the end who can actually handle it. This is different than errors that you can handle right then here. So if there's a small error it can correct, then it should do it. But if it can't correct, it doesn't have the information. It doesn't know what we're doing this for. So it really just passes the error along. And also, if this is cleaning up something that was done before, you want cleanup code to execute still. So you don't want to just say error, bounce back, because then this doesn't have a chance to say there's an error, I've got to do something. You want to actually pass it through. So in the framework I use, I've got too many of these stupid animations. If there's an error comes in as a message, when you read a message, if it's an error message, the error comes out the error wire. And if you reply to a message, that's basically I'm told to do something and then I reply, I'm finished. If there's an error in the action, it's actually sent out as an error message. So whether it's, oops, backwards, I missed something. So basically you're connecting the error message and the error clusters are sort of connected together. So an error message can become the error cluster, carry through some sub-PIs, and when you go back to asynchronous, it goes back to an error message and comes out. So if I had an error here somewhere, then the error would pass through and go in an error message back to whoever actually knows what to do about the error. And again, remember, this is different than an error that you can handle. So there's an error you can handle right away. I can fix it right here. And there's an error you can't, in which case you want it to chain it along. So that's one thing. Another thing to think about with asynchronous processes is if you have one process sending a message to another process, and there's not an error in the action, but there's actually an error in communication, like there's a break in communication, whose problem is it? Because when you have asynchronous processes, you got more than one thing that could be the problem. And you can have an explosion of it, there's 6 things going on. You don't want all 6 of them to have an error and have to throw 6 error messages. You got to figure whose problem is this, have them deal with it, and everyone else should ignore it, because it's not their problem. And to think about there is, was this message a command or a notification? A command is this guy is instructing this to do something, right? This guy is just a servant. Its job is just to handle commands. And this guy's in charge. So if it breaks, it's this guy's problem. It's not this guy's problem. He's still ready to handle commands. But if it's a notification where this is a piece of information that this guy needs, and then it's not this guy's problem because he's doing whatever he's doing and sending notifications. It's this guy's problem because he's not receiving them. So in each case, you want to say, if there is a problem, you want the error to, you want only one person to have the problem and have to deal with it. So you want to find where is a natural place. So if it's a notification, this guy needs something to know if this is broken, if it's possible to break. If it's a command, well, it's relatively easy because when you try to send a message, it'll throw an error. So in the code package that I use, again, for example, this guy, he'll send any replies off, but he won't throw an error if this communication channel is blocked. And the reason is this code is in someone whose job is to handle messages, handle commands. And where it goes is not its job. So if the code that sent the message gave the wrong address or something, or gave an invalid address, that's not this guy's problem. He doesn't know what to do with it. So reply never throws an error, but it will send error messages through. And that's the way of simplifying when you're dealing with many things talking to each other. Because otherwise you get like an error happens, and this guy throws an error, that guy throws an error, this guy throws an error. And most of these guys don't know what to do with the error. So I follow the form of one guy's in charge of the error, and everyone else can ignore errors if they don't go into some kind of fault condition. There's a third kind of error where you have an error, now you're in a fault condition, so you need to have a different state.
I think it's in some ways that's a bit similar to how Canvas works. It's very similar kind of affair. Chucks an error, and they all down the line they acknowledge the error, but if they don't receive it back, the one chucking the error then closes down.
Yeah,
you know, it's I've never really fully got my head around it, but it does sound.
But you got to make sure that someone is in charge of the error. The errors aren't ignored by everybody.
Yeah.
But usually you follow the chaining where I initiate an action, and then I get the result. And if the result's an error, then well, that's my error because I tried to do something.
Yeah, Canvas is quite brutal on the low level. Is what it does. It shuts it down. The node is causing the error. Just that's it. I'm done.
So that's it for the error handling.
Fixer?
Can I do my other one?
No. No, I've got mine. No. I've got one more to do on that. No, I've got you lined up. You're lined up to do it. It's me. Right, well, you'll see something very familiar. So, what I tend to do now, and I kind of like it, is that I have yet another loop, and we'll see it as we go through a code review, but at the bottom of my loop, very similar to the way that we queue up our transitions and we queue up our user interface stuff, I now queue up my errors and handle them. So this is your main VI. One of the loops that is under my main VI is my error handling. And to report it, we didn't talk about this, did we, James? Is I have at the end of all of my other loops, and anywhere else really, is again, I'm naming the loop, numbering the loop, titling it, and I capture the error. And all that is doing is bumming it on the queue so that my error handling queue can handle it. But it goes a little further than that because this is a distributed system what I'm doing here. Actually what I want is all distributed nodes to queue up errors as well. So if you look at the error handling on one of my RT boxes, for example, it's CBR, it's pretty much the same. It's a queue that captures all the errors coming in. But instead of actually doing anything with it at the RT level, what it does is it chucks it up as a message to my other system. And to make it kind of simple, so this is my error component, the internals. I set the error, did the display message. Oh, I think that's got the wrong bit.